Let's see how these organolithium and magnesium compounds can be added to carbonyls. So the good news is you already know the mechanism. We've talked about the mechanism for adding hydride to carbonyls, and this is going to be no different. The only difference is instead of adding H-, you're going to add some carbon minus. But mechanistically, it's identical. So if we start with an aldehyde or ketone, we're only going to be able to add that nucleophilic source once because there's no leaving group on the carbonyl. And this could be CH3 magnesium bromide, or it could be CH3 lithium. Both reagents are essentially interchangeable for our purposes, and we're going to treat this as CH3 minus. That's our nucleophile. So let's do this reaction. We're going to predict the product by going through the mechanism. So here's my CH3 minus, my first nucleophile, just like we did with the hydride. Use those electrons to form a bond with the carbonyl carbon. And then we push those electrons up to the oxygen. Now at this point, we don't have a good leaving group attached to the carbon. We have a phenyl, a methyl, and a hydrogen. None of those are good leaving groups, so you're stuck at the tetrahedral intermediate. This is when you add acid. And the acid protonates the O-. So we're left with an alcohol. And we can simplify this by implying the hydrogen if we want. Either way is correct.